Okay, so we have carboxylic acid. This is the last functional group that we are going to discuss. And take note of our general formula for our carboxylic acids. We have RCOOH. So that's the characteristic of the carboxylic acid. If you see in the structure or in the formula C double bond O and OH, automatically that will be a carboxylic acid. And this will be still under the functional groups with carbonyl carbons. So remember, or carbonyl groups class. Remember last time when you say carbonyl group, it always contain carbon double bonded to oxygen. So the carbon there in COOH is double bonded to one of the oxygen. And then the other bond will be for the OH. However, carboxylic acids are not just linear or aliphatic, but we can also have carboxylic acids that contain aromatic ring. So pwede din naman an aromatic ring plus a COOH that will still be under the carboxylic acids. So this functional group will be our organic acids. In our inorganic chemistry, we identified a lot of inorganic acids, and mostly they are classified as strong acids. This time, the organic acids, or those which contain carbon, are most likely classified as weak acid. Okay. Sige. So, we have nomenclature. So how do we name our carboxylic acids? We have common names and we also have iupac names, syempre. For the common names, this uses Greek letters to indicate positions of our substituents. So anong ibig sabihin yung mga Greek letters na yan? We have here the alpha. So pag sinabing alpha yung position of the substituent, that will be the carbon next to the COOH. So this one is the COOH and this is called the alpha carbon. Now, if the substituent is found here, we will be using this symbol. Okay? For example, alpha methyl. If merong methyl group dyan ha, alpha methyl siya. If dito siya sa carbon right after the COOH. And then pasunod na yan siya, beta, sigma, epsilon, and yung mga Greek letters natin. Kasunod yan siya kung how many carbons are there sa ating whole formula. So pasunod after the COOH, we are going to use the Greek letters to indicate the positions of our substituents. So often, the names or the common names of our carboxylic acids are derived from their Latin Greek name. So most of the time, they were named from their original source. So anong examples of the common names of our acids? Actually, yung mga formic acid, which are also found sa ants and bees sa sting nila. Pag nakakagat tayo ng bees and ants, diba, it's most likely itchy at the same time painful. So that will be due to the released formic acid. And then aside from that, remember formic acid is an oxidation product of primary alcohol, which is the methanol. I mean methanol mismo. Pag nag-oxidize yan siya, it will become a methanol or the formaldehyde, and then further oxidation will give us the formic acid. And this will cause blindness. When you say formic acid, that is referring to one carbon carboxylic acid. And then we also have like acetic acid. This one naman is for 2 carbon na carboxylic acid, which is also found in vinegar. So yun yung mga examples of the common names of our carboxylic acids. But when you say iupac names, syempre, we will be using the rules here, which is actually similar to that of the alkanes. Okay? Parehas sila ng alkanes. Kaya lang, we are going to change the ending from E, di ba? Alkane ends with an E. Instead of the E, we are going to change it with OIC, and we are going to add the word acid. Okay? So again, since I mentioned that this will follow the rules for, wait lang ha, nagsulod ang tubig. Okay, sorry for the interruption. Abrim niya akong tapad na na window. Nasulod ang tubig. Tingala ko na may mga tubig-tubig akong laptop. Anyway, again, this will follow, class, the rules for the naming of the alkanes, wherein the first part is you are going to identify the longest chain, and that will be called our parent chain. But you have to take note that the parent chain should bear the COOH. Dapat andun si COOH, class. Kasali siya sa pag-count for the parent chain. And that the carbon number 1 will always be the COOH. So, ganun yung pag-identify ng ating parent. Okay, sige. So, just like this, remember when you say methane, class, let me get my pen. I'd like to write sa screen. Sige, so di ba methane is CH4, that's one carbon alkane, but for carboxylic acid, COOH, or the formic acid, which is its common name, is called methanoic acid. So I told you, get rid of the E in the ending for the alkane and change it to OIC and add the word acid. So this is the iupac name for one carbon carboxylic acid. Okay? Mahina ang audio? Mahina ang audio ko? Naka-full man ata ito. Yung sound.
Okay lang sa ako. Headset.
Mahina lang siguro yung connection. Okay. Sige. Now, we have different kinds of acids, class. Number 1, based on the number of carboxyl group. So, meron tayong tinatawag na monocarboxylic acid, which are also called saturated fatty acids, or those that contain one carboxylic acid group. So, pag merong isang COOH lang, syempre, we call that monocarboxylic acid. So what are the examples of our monocarboxylic acids? These are their common names. These are not their iupac names. So one carbon, I told you a while ago, this is called formic acid, and then acetic acid, propionic, butanoic, valeric, caproic, enanthoic acid. Just add the word acid, ha. And then caprylic acid, pelargonic acid, up to 9 carbons. I don't actually have a mnemonics here for 1 to 9, but I do have a mnemonics for 10 to 20. So ito, the numbers there are referring to the number of carbons present in the formula. So ano yung ginagamit natin na mnemonics here? Kalamay, pasta. Yung ginagamit na mnemonics. Kalamay, pasta. That's from 10 to 20. And there will be an interval of 2 carbons from 10 to 20 class. So 10, 12, 14, 16, 18, and 20. So Ka for capric, La for lauric, Mai for myristic, Pa is palmitic, ST is steric, and 20 carbon class na carboxylic acid na saturated saturated. So, lahat ng carbons dyan are bonded using single bonds only. So, the 20 carbon carboxylic acid is called arachidic acid. Arachidonic acid is different. Though arachidonic acid also contains 20 carbons, but meron kasi siyang double bonds. So, iba siya from arachidic acid. And you know what arachidonic acid is? It's our precursor for our prostaglandins, for example. Okay? Clear this. And then we also have dicarboxylic acid. So these are the acids which contain two. Meron silang dalawang COOH. So kagaya na, syempre, sa 2 talaga tayo magsa-start. Meron tayong oxalic acid. For example, oxalic acid is HOOC-COOH. So this is the chemical formula of our oxalic acid, or simply we are going to write it like this. Dalawang COOH is called oxalic acid. And then I think we have mnemonics here. Oh my, such good apple pie, sweet as sugar. I can still remember this one. This has been a mnemonics used for the dicarboxylic acids that we have. We have, oh my, such good apple pie, sweet as sugar. Sila gumawa nan. Yan, just to remember the first letters for each name of the dicarboxylic acid. So like pag tatlong carbons na dicarboxylic acid, that's my malonic, succinic, glutaric, adipic, pimelic, suberic, azelaic, and sebasic acid. Again, just add the word acids sa kanilang name. Okay? So I hope naintindihan yon. This one is for monocarboxylic acid. Pag mono, isang COOH. And ito naman, this table is for the dicarboxylic acids. Again, merong dalawang COOH. Okay, and then we have monobasic or monocarboxylic acids. These are acids which contain one COOH pa rin, but unsaturated. Bakit unsaturated? They have lesser amount or lesser number of hydrogen because of the presence of the double bonds. Okay, so just like oleic acid class is the common name, and then the iupac name is, we have here the cis-9-octadecanoic acid, meaning on carbon number 9 we have a double bond here. And then we have linoleic acid, cis-9 cis-12 octadecadienoic acid, and the linolenic acid is cis-9 cis-12 cis-15 octadecatruenoic acid. So actually, these two, these three, if I'm not mistaken, contain 18 carbons all in all, but they differ in the number of double bonds. So oleic acid only contain one double bond. The linoleic acid, 2 double bonds, and the linolenic acids, 3. So you can see that on the numbers. So yung oleic acid, carbon number 9 lang, si linoleic acid 9 and 12, and si linolenic acid 9, 12, and 15. So si linoleic acid class is also called omega-6 fatty acid. And the linolenic acid is also known as our omega-3 fatty acid, which is known to be good for the heart. Okay, good for the heart siya. Si linoleic acid, though this is unsaturated fatty acid, is not good for the heart. This can be found in our vegetable oils na ginagamit natin for cooking, just like the coconut oil or the palm oil. Meron yan siyang omega-6 fatty acid. Again, that is not good for the heart, only the omega-3. Okay, now other examples of our acids, I have mentioned this acetic acid is an acid found in vinegar, which can also be spermatocidal. What do you mean by that? This can kill sperm cells. So remember, the sperm cells of our males would thrive in an environment that is dapat alkaline. So alkaline dapat yung environment nila. However, if you place these sperm cells in an acidic environment just like in acetic acid, they will surely die. So that is the reason why during fertilization, this is not new sa inyo ha, na millions of sperm cells will be released by that time, but only one sperm cell will fertilize one egg for the female. So, bakit millions? From the vagina itself plus the vagina of the female is most likely acidic. So, kaya nga tayo may lactacid na tinatawag, di ba? Lactic acid. So, that is patterned with the pH of the vagina. Hindi advisable to use soap when you are going to wash your genitals, since soap is alkaline in terms of pH. Now, kapag yung sperm cell dumaan sa vagina, there will be some na mamamatay sa vagina pa lang, kaya marami yung nire-release. So, yung nakaunang mag-fertilize, ayun na yung magagamit for the fertilization of the egg and yung sa pagbuo ng bata. Okay? And then we have benzoic acid, which is used as an antifungal agent. So actually, benzoic acid is found mostly sa mga preparations for fungi. So does salicylic acid. So this one naman is keratolytic agent. When you say keratolytic agent, this one causes sloughing off of our skin so that the agent can penetrate and can kill or prevent the growth of the fungi sa skin. So, di ba, mostly we use salicylic acid if the person has anong tawag dyan? Ganinang magputi-puti. Like up, or like mga pityriasis versicolor. Yeah. And other fungal infections sa skin. You can use the salicylic acid. So, all your internet connection is unstable. Wait lang. Kasi alipo nga is ano, diba? Ano tawag athlete's foot. Up mo na itong magputi-puti. Ang unsa, I think that is still a fungal infection sa skin, pero I cannot describe it kung sinong anan. But anyway, all of these are examples of carboxylic acids. They are acids class. They do contain COOH in their structure. If we're actually going to write, the acetic acid is just CH3COOH. While the benzoic acid, from the name itself, you have the benzene ring and the COOH. And then the salicylic acid is also a benzene ring with the COOH and OH here. That's the structure for our salicylic acid. Okay, so you still have the COOH. All of them contain carbon, so they are organic acids. And lastly, these are the carboxylic acid derivatives class. So under pa rin sa carbonyl groups na functional group kasi they contain C double bond O, but they are produced from carboxylic acid. So just like esters, Our general formula for esters is RC double bond O OR. So how are we going to produce this ester? Actually, ano ito? Reversible ito na equation. So when you have a carboxylic acid and then you have it reacted with an alcohol, that's the time you get to have you have the RCOOR or the esters. Pero you can still get back the acid and the alcohol just by adding water to the esters. We call that hydrolysis. Okay? Yung equation na nasa screen is called hydrolysis, the addition of water to our esters for us to get the carboxylic acid and alcohol. Now, most of the esters have pleasant odor class just like our methyl salicylate, which is the ingredient of our liniments. Just like, anong brand nga? Anong brand yun? Efficacent. Yeah, Efficacent has methyl salicylate. So upon hydrolysis, so again, this one is an example of a hydrolysis reaction. You will get an acidic unpleasant odor. So baliktad, if you have an ester, you have a pleasant odor, but if it undergoes hydrolysis, mabaho na siya. So you will really identify whether your esters class are still okay or not. Pag nagbaho na siya, meaning nag-undergo na siya o hydrolysis na process. So aside from the esters, anhydrides are also derivatives of our acid, and actually they are just products of two carboxylic acids reacting with each other. So again, you have two carboxylic acids reacting, you will get the anhydrides, and this is our general formula for the anhydrides. You have there R is any functional group. So it can be an alkene, alkane, alkyne, aromatic ring, or whatever. As long as you have there the CO, and then you have an O at the center, and then another CO. That is called again anhydrides. And then lastly, amides class are also under the carboxylic acid derivatives. What is their difference with amines? Amines are just RNH2. This time, amides contain C double bond O. Ito C double bond O. Ito C double bond O. Ayan. So you have R, any functional group, C double bond O, and then NH2. How can you get the amides? You just have the carboxylic acid react with ammonia. You will get this one. Now, just like the esters and the anhydrides, amides also undergo hydrolysis. So when you say hydrolysis, there is the reaction of water there for our acid derivatives. Now, if there is water na mag-react with amides, you will get again the carboxylic acid and the ammonia. So all of these class are derivatives of our carboxylic acid. So actually that ends our discussion for organic chemistry. Any question or clarification? Wala. Sige.